Hello students, welcome to this lecture. In this lecture, we are going to discuss about concepts of balance sections. This is the second lecture in this series. For design of any reinforced section, it is very necessary to understand the concept of balance, under reinforced and over reinforced sections. So, let us discuss these concepts in detail one by one. So in this lecture, we'll consider the concept of balance section. So in bending, the strain varies linearly across the cross section of the member. This we have considered or we have discussed in the last lecture also in the assumptions that as per the assumption number 1 in limit state method, that the plane section before bending remains plane after bending. It means that whatever strain variation is there, that strain variation will be a linear strain variation. So to understand this, let us consider a simply supported beam which is subjected to an external load, and due to this load the beam may get deflected, or the beam is subjected to flexural action, and due to the flexural action, that the one edge of the beam is in maximum compression and the other edge of the beam is in maximum tension. So this is the typical flexural action, that one part of the beam is subjected to compressive stresses and the other part of the beam is subjected to tensile stresses. So by considering this phenomena, if we consider the section of this beam, that is the rectangular section, and to sustain the tensile stresses the reinforcement is placed, then the maximum compressive strain which is going to take place in this concrete at the outermost compression fiber, that will be equals to 0.0035 as specified by IS 456 in assumptions, and the corresponding maximum strain in steel, that is epsilon s, will be equals to epsilon su value, again as per specifications of IS 456 in assumptions. Hence, if we see the strain variation of these two values, this strain varies linearly, and as we can observe here that across the depth of this section there is a particular point where this strain value becomes 0. At this point the strain value becomes 0. So this particular point is called as a neutral point, and the axis passing through this point is called as a neutral axis. The depth of this neutral axis, or the perpendicular distance between the extreme compression fiber and the neutral axis, is called as a depth of neutral axis, and this depth of neutral axis is represented by xu. Capital D is the overall depth of the section. Small b is the overall width of the section. Small d is termed as effective depth, and this effective depth is nothing but it is the perpendicular distance between the extreme compression fiber and centroid of the tensile reinforcement. Then the distance, perpendicular distance between centroid of the tension steel and the extreme tensile fiber of this concrete section, that will be called as a effective cover. So these are the some terms which we are going to use frequently, that is B, D, small d and E. These are the some terms XU. These are the some terms which we are going to use frequently in further lectures. So this point is very important for the understanding the concepts of over-enforce, under-enforce and balance sections. Now let us discuss the concept of balance section. For this, let us consider one rectangular section having the dimensions of capital D as the overall depth, small b as the width, small d is the effective depth of this section, and the balance section is the section in which the maximum stresses in steel and concrete reaches to their permissible stresses at the same time. Means that as we know that the maximum compressive strain which is permissible strain by as 456 is 0.0035 and the maximum permissible tensile strain is epsilon SU, that is equals to 0.87 Fy upon Es plus 0.002. These two values reaches simultaneously, means that both the materials, that is concrete and steel, is stretched or stressed or strained at the same time to the maximum capabilities, then that particular section is called as a balance section. In simple way, we can say that both the materials are stressed to their fullest capacity at the same time, and that particular section is called as a balance section. The corresponding neutral axis for this balance section is sometimes referred as critical or limiting neutral axis, and the depth of this neutral axis is termed as critical depth of neutral axis or limiting depth of neutral axis, which is denoted by XU limiting. So this is about the balance section. This balance section is just as an ideal section which we have to consider for the design purpose. Here we stop. In next lecture, we'll discuss about the under-reinforced sections. Thank you. If you like this video, then don't forget to click on like button, and also if you want to get the further notifications about the videos like this, then click on the subscribe button and again click on the bell icon so that you will get the notifications of my new videos on this topic. Thank you.